Hi, welcome back to Calculus. We're looking today at section 3.9, inverse trig functions and their derivatives. So these are just a great big ugly mess. Feel free to look in your book. It's got all of these in there, and yeah, that's good because, like I said, they're kind of a mess. So here we go. I'll just run through them real quick, and we'll do a couple of examples. Actually, we'll do exactly 2 examples. This should be a reasonably short section. The derivative with respect to x of sine inverse of x is 1 over the square root of 1 minus x squared. Again, remember, anytime you see a negative 1 on a trig function, it's not an exponent, it is an inverse. The derivative of cosine inverse of x is the opposite of 1 over the square root of 1 minus x squared. The derivative of tangent inverse is 1 over 1 plus x squared. Derivative of cosecant inverse is the opposite of 1 over the absolute value of x times the square root of x squared minus 1. That's a mouthful. Derivative of secant inverse is 1 over the absolute value of x times the square root of x squared minus 1. And for cotangent inverse, its derivative is the opposite of 1 over 1 plus x squared. So an interesting case where the tangent and cotangent are kind of really the easiest of the derivatives. But yeah, you're going to want to keep these handy because these aren't the kinds of things you really want to do a whole lot of memorizing for. But yeah, anyway, there we go. So let's look at 2 examples. We'll do one on the next board, and then one more after that. All right, so let's go ahead and take this derivative. Find y prime, where y is equal to the cosine inverse of 1 over x. So, as always, if you have a chain rule, it's really not a bad plan to identify that inside piece first and take its derivative. So, I'm going to let u here be 1 over x, and I noticed, because I prefer to do it this way, that that is the same as x to the negative first. And that's useful because then when I take its derivative, I can drop the exponent down front, and I can subtract 1. Remember, negative 1 minus 1 is negative 2. Just be really careful there. Sometimes people turn that into a 0, and that's not quite right. And so if you clean that up, you get negative 1 over x squared. All right, so now let's attack y itself, now that we have du dx. Y prime will be the derivative of cosine inverse with 1 over x on the inside. So that is the opposite of 1 over the square root of 1 minus 1 over x squared. So I'm just using that derivative of cosine inverse with 1 over x in place of the x right there. And then times du, so negative 1 over x squared. All right, so that's a mess, and it seems like we should be able to clean this up a little bit, and we're going to, and that's really all the rest of this work is to clean up the mess a little bit. So the first thing I did is I just brought the square in, and so 1 squared is 1, x squared is x squared. Then I got a common denominator. So the common denominator here is x squared. So another name for 1 would be x squared over x squared, which means that all of this turns into the square root of x squared minus 1 over x squared. Okay, so I'm just putting those 2 things together. So you can see I now have 1 over the square root of x squared minus 1 over x squared times 1 over x squared. And then when I split the square root here, the top stays as that nasty square root of x squared minus 1. But the square root of x squared is the absolute value of x. We don't know if x is positive or negative here, okay? But what we do know is that if you square anything, it turns into a positive. And then the positive square root of that positive thing is going to be positive. So we have to use an absolute value of x when we split that up. So then I take advantage of the fact that I have 1 over a fraction, and that's the same as if I just use, it's the reciprocal. So I just flip that back over. I get the absolute value of x times the square root of x squared minus 1 times 1 over x squared, and then I smash it together, giving me my answer of the absolute value of x over x squared times the square root of x squared minus 1. So it is a mess. I think that the hardest part of it is definitely the algebra to just kind of clean it up a little bit. So just be really careful as you go through. All right, one more example, and then we're going to call this section good. Like I said, short little video for this one. All right, here's our last example, and I don't know, the algebra on this one actually ended up being quite a lot nicer than the last one. So we want to find y prime again if y is equal to the tangent inverse of the natural log of x. So again, I have something embedded inside of my inverse trig function, right? I have this natural log of x there, so I called that u. This time the derivative of that is just 1 over x. We know the derivative of natural log of x, that's it's just 1 over x. So now I'm ready. I can take the derivative of tangent inverse, and then I'll multiply by this one at the end. So derivative of tangent inverse is 1 over 1 plus, it's usually x squared, but since my inside piece is natural log x, I get 1 over 1 plus the natural log of x squared, and then times my du dx right here. So just kind of combining those two fractions, it's just multiplication, so I get 1 over, I put the x first, it's kind of like that way, x times 1 plus the natural log of x squared. Please be careful. Natural log of x squared, like I have it written here, so let's write this down. The natural log of x squared is not the same as the natural log of x squared. Okay, so be really careful. Keep the square here outside of these parentheses. That would be very useful, especially if you're really unfortunate and had to take a second derivative. All right. But anyway, there we go. So there's our derivative for that function. Have a wonderful day.